Alright, question 1 is stating the figure below shows the graph of f prime, the derivative of the function f on the closed interval -8 is less than or equal to x less than or equal to 6. The graph of f prime has horizontal tangent lines at x equals -3 and x equals 3. The function f is twice differentiable with f of 1 equals -2. Here we have a graph of f prime and the derivatives of f double prime and f prime. For part A, it's asking find the x-coordinate of each local minimum of the graph of f and justify your answer. So at which coordinate do we see that f prime goes from negative to positive? The answer is 1. F prime goes from negative to positive as seen here. Part B is asking find the x-coordinate of each of the points of inflection of the graph of f and justify your answer. So at what 2 points does f double prime change its signs? The answer is -3 and 3 and 3. At -3 f double prime is positive, and at positive 3 f double prime is negative. So those are your points of inflection of the graph of f. For part C, it's asking find all intervals on which the graph is concaving down and has a negative slope, and explain your reasoning. So from 3 to 5, the slope is negative and is concaving down. So those are your 2 points of interval, 3 and 5. For part D, it's asking you to sketch a graph of -8 is less than or equal to x less than or equal to 6. There really isn't much to elaborate on. I mean, the only thing to explain is how to find f prime and f double prime. So how to find f prime? Okay, so if the slope is below this line, anywhere below this line, it's going to be negative, and if it's above this line, it's going to be positive, no matter if the slope is going up or down. For f double prime, it's kind of the opposite. If the slope is going up, as in this portion right here, then f double prime is going to be positive, and if it's going down, like as seen here in this portion right here, then the f double prime is going to be negative. And then again here, how it's going up, it's positive, and it's continuing to go up, it's positive. It's coming down here, negative, and in this portion right here, it's also going down, so it's also negative. So that's basically it. Alright, question number 2. Let g be a function defined on the closed interval -8 is less than or equal to x less than or equal to 8, with g of -8 equals -2. The graph of g prime, the derivative of g, consists of 2 semicircles and 2 line segments as shown below. So here's another graph of derivative f prime and f double prime. For part A, it's asking for -8 less than x less than 8, find all values x at which g has a relative maximum. So at -4, f prime is positive, went from positive to negative. F prime went from positive to negative at 4. For part B, it's asking to find the point of inflection. Basically, where does f double prime change? At -6, it's positive. At -2, it's negative, and then at 4, it's positive. So it went from positive, negative, positive. F double prime changed 3 times. For part C, it's asking to find the intervals on which the graph of g is increasing and concaving up, and explain your reasoning. So if you look at the graph, at -8 and 6, at -8 and 6, the graph is going up, and from 0 to 4, it's also going up, and f double prime is staying positive on both those intervals. For part C, it's basically just asking to sketch a graph of negative 8 less than or equal to x less than or equal to 8. And here's the graph to show it. That's basically it. Alright, my last question, question number 8. The graph above represents f double prime, the second derivative of the function f on the interval negative 7 is less than or equal to x less than or equal to 8. For part 8, it's asking me to state the intervals on which the graph of f is concaving up. So from negative 2 and 2, the slope is going up and f double prime is staying positive, so that's where the graph of f is concaving up. And those are my two intervals, negative 2 and 2. For part B, it's telling me to state the intervals on which the graph of f is concaving down. So from negative 6 and negative 2, you can see that the slope is kind of going down and then it goes up, but f double prime went from positive to negative, and therefore it's based on that it's concaving down. And also at 2 and negative 4, where f double prime went from positive to negative, and you can see that the slope is kind of going down, but then it goes back up, but f double prime changed signs, so therefore it's concaving down. For part C, it's asking me for what values of x does the graph of f have a point of inflection. Justify your answer. That is easy. It's negative 2 and 2 because f double prime changed signs. It went from negative to positive. And that's it. Thank you for watching.